Okay, folks, this is the procedure video for the Torx lab. And so as we've been talking about, you're going to be balancing a meter stick, right? Oh, I should probably make it a little bit bigger than that. You're balancing a meter stick. You're going to be hanging it from a ring stand. I'm not going to draw that. You'll see that in lab. We're going to do that in the density lab too. Make sure you set it up again so you have 0 centimeters over here and 100 centimeters over here. You're going to start out with part one, that your axis is going to be at the center of gravity. So your rotation point is there. Okay. In part one, the goal is to prove to yourself what we said about torques in equilibrium. So you're going to get your system in equilibrium, and you are going to show that the sum of the torques is equal to 0. The positive torques equals the negative of the negative torques, and you're going to do that in a few different ways. Okay, but that's your goal, is to prove that this is true. Okay, so you're going to prove that in equilibrium, when the meter stick's not moving, that the torques are equal to 0. So you'll step through the procedure on this. First one, you're going to hang 2 different masses, right? They are different masses, and the masses are greater than 50 grams. That's the mass of the little hanger, so you got to put something on there, right? You're going to hang 2 different masses. Those masses are going to have 2 different lever arms, or that'd be R1 on this side and R2 on this side. You'll see in your data sheet that you will need to write down a bunch of stuff. Okay. So one of the things you're going to need to write down is position. So when I say position, that's different than lever arm. Okay, so position is where the mass is on the stick. Okay, so I did this in the previous video, but for example, position 1 would be right here. If this is 35 centimeters, then position 1 on your data sheet equals 35 centimeters. Okay, then R1 is where you do the math and you say, oh, that's the difference between, if the center of gravity is at 50, then that's the difference between the two, and you do the calculation. So I want you to write all of those things down. You'll calculate positive torque, negative torque, etc. While I'm thinking about the data sheet, before you even get to this first part where you're thinking about those torques, you have to do some initial measurements that you're going to need before you do the setup. So you'll take some initial data, and for that initial data, you'll do things like you'll take the mass of your meter stick, and you'll take the mass of a few other pieces. You'll have a lead piece, you'll have a cylinder, and you'll need to take the mass of your clamps. This is sort of the important part. These clamps are these little things that slide on the meter stick, allow you to hang the weights on them. They have mass, so they will provide a torque. You take the mass of all 4 together, and then you find the average mass. So that way you don't have to keep track. Oh, that's a terrible way to spell average. Okay. Anyway, you take the average mass. So that way you don't have to think, oh, clamp 1 was 18 grams and clamp 2 was 20 grams. You're just going to take an average and use that in your calculations. Okay, so that's your initial data. Part 1, sorry, that was kind of an aside. Boop. Part 1 continued. Right, first you hang 1 mass on each side. If we continue in part 1, look at your procedure. It's going to go through all this. The second part of part 1 is that you hang 2 masses on one side, and then you hang 1 mass on the other side. And you balance that, and you think about what are the torques on this side versus the torques on that side. Okay. All right, so basically you'll need to fill out all of your data sheets And there's not really room for calculations, but please show me your calculations of torque on a separate piece or even sort of in the margins is fine. Make sure to show those calculations. Part two, so part one is that you are proving that at equilibrium the sum of the torques is zero. Part two, you're just going to assume that, right? Hopefully you believe it now that when it's in equilibrium that the sum of the torques is equal to zero. And then you're going to use your meter stick to measure mass. You're going to use it as a balance, a primitive kind of balance to measure mass. And we're going to measure mass of a few different things. First, you're going to have an unknown. That's the cylinder. Okay, so the mass of the unknown, here's your meter stick. I'm going to do this. You'll have the cylinder. This will be the unknown. And you're going to hang some masses over here, calculate torques to figure out the mass. How do I measure mass? Go back to your equation, your torques balance equation, right? And we simplified it as saying M1R1 equals negative M2 R2. If your unknown is M1 and your known is M2, you are going to know, you're going to measure the different lever arms, and you're going to know what this mass 2 is, so you solve this equation for M1, right? And that's the procedure. You might not always be solving for M1, but you're going to be going back to this equation and thinking about what you know and thinking about what you don't know. Okay, so that's the first part of part two. Then you have this part, actually it's number 3 in your procedure, where you find the mass of the meter stick. So here's where that center of gravity comes in. In this case, you'll have one hanging mass, and you're going to balance it with the mass of the stick. So that means you're going to move your center, move your axis off of the center of gravity. Okay, because the center of gravity is where the force works instead of just the stick by itself. Okay, so that way you're going to find the mass of the stick. Then, as we go down, and all of this, if you see on your data sheet, all the numbers are all matched up to the procedure, so you can figure it all out there. The next thing is you're going to use a loaded stick. And so when we say a loaded stick, that means you're going to take your meter stick and you'll have this little lead piece that you can kind of fold on one end. And so now you're going to imagine that that lead piece doesn't move and that now you have a meter stick that is asymmetric. That the mass is not distributed symmetrically around the center of gravity of the old one. So now you have a new center of gravity, right? The center of gravity is not in the same place as with the loaded stick. So what I want you to do is find out where is the center of gravity of that loaded stick. And you're going to do it in 2 ways. The first way is just sort of an experimental way, and the second way is a calculation. And then you are going to do a percent difference. Be careful when you get to this part, especially the second way, the calculated way. When you're calculating, you can't use the experimental value, right? So if you get stuck with that calculation, just let me know. Follow all the procedure. Fill out the whole data sheet, and you'll be good to go. Okay. Alrighty. So I think that is pretty much it. Come to class, read your lab manual, be prepared, and all of that, and I will see you then.